we're starting with 2.5. And some people actually think this is easier than other stuff, but the reason why I did not put it on the quiz is because it goes hand in hand with 2.6, and 2.6 is it's like a step above as far as level goes. So that's the moral, or that's the reason why I did it that way. So as you remember, functions are where x values cannot repeat. And the reason why I'm bringing that to your attention, because we did that in an earlier unit, is if something is 1 to 1, well, the first one is explaining that the x values cannot repeat. The second one that's written in this phrase is saying that y values cannot repeat. So as we move forward to exercise 1, we have two functions for you. And yes, these are both functions. It's written in function notation. F of x equals 2x. And let's use a different color. G of x equals x squared. So if you remember from the earlier unit when I asked you to do a domain with a range value, we plugged in -2 into the f function. Well, 2 times -2 is -4. And then when we plugged in 0 into the f function, 2 times 0 is 0. And then plugging 2 in, 2 times 2 is 4. But as I look at the other function, if I were to plug -2 in here, don't forget that -2 squared actually means -2 times -2. So you get +4. And if I plugged in 0 in for x, 0 squared is 0. You're probably curious why I wrote it this way. Sometimes we go from least to greatest. Some math teachers are like that. But then also when I plug in 2 squared, I also get 4 again. So what I'm trying to get at is for the function g, let me highlight it, this value repeated. So when that y value repeats, as I mentioned, then that's our clue that g is not. And sometimes we write it out like 1, 2, 1, like this. And the whole point is that for two different x values, I had two different x values that went to the same y value. Whereas if I look at the graph of or domain and range of f, no y values repeat. So for each x value, there's exactly one y value. And I mean, I know this is written in a very, very confusing way, but this is actually what you'll see in a math book. A function f of x is called 1 to 1 if x subscript 1 does not equal x subscript 2, then that implies that the y values do not equal each other. And he even tried to put it into different words, which in my opinion, an easier way is just say, make sure the y values do not repeat. And that is my opinion. So if you plan on taking a future math class, you might see this written down, and then you might need to just think back, oh yeah, that was when Mr. Higbee said the y values cannot repeat. But as we look at exercise 2, in order for it to be a function, make sure that the x values do not repeat either. So if you see a 1 to 1, that's basically saying x and y cannot repeat. So as I'm looking at this problem, it is multiple choice to determine which is and explain why the others are not. Well, as I'm looking at this first one, the x values repeat, so therefore it's not even a function. So if it's not a function, how can it be a 1 to 1 function? So then as I look at exercise 2, well, finally it is a function. But then look at the y values. So the 1 repeats for a y value. In other words, it is a function based off the x values, but it's not one-to-one. And by the way, we typically write it out. This is just like extra. Some people will actually write it like this, but I've actually seen students get confused. They're like, what's the absolute value of a negative? And it's actually supposed to be like 1, and then that hyphen means 2, and then 1. But I try not to write that out because I feel like it gets confusing. But if you see anybody else write it that way, that's fine as well. So do you see any issues with number 3? X's do not repeat. Y's do not repeat. So this is the one we want. And there's a lot of things wrong with option 4. First of all, it's not a function. And then second of all, there's y values that repeat. So this one's just terrible. That's not a good explanation, by the way, that I'm just pointing it out, that it's not a function and it's not one-to-one. So moving forward to exercise 3, you might want to take a trip down memory lane on how we could determine whether or not these things are functions. So the first directions, let's just switch colors, is asking you which ones are. So we're going to circle the 2 that are functions. And how did we tell if something was a function or not based off of looking at the graph? Is if it passes the vertical line test. Okay, we did that a couple weeks ago. So as a reminder, you may have forgotten, is when you draw a vertical line, if it hits more than 1 point, like this one does, it hits 1, 2, 3, 4 times on that curve, that's basically another way of saying that the x values repeat. So option 2 is not even a function. Same thing with option 3. If you look at option 3, you can draw a vertical line anywhere. It doesn't have to be right there. It could be over here. It only has to fail the vertical line test once. So I'm trying to think of another way of explaining it in case you're still confused. Anyway, I hope you are convinced then that 1 and 4 are both functions. They pass the vertical line test everywhere. And that's all the explanation I need, that you're showing me that you understand the vertical line test by getting the right answer and writing that down. Now, as a reminder, this is used to show that x values repeat. So there's probably also a test if y values repeat. So let me do a different color. There's probably a test to show that y values repeat. And if you were thinking, well, if vertical lines are made for x's, then maybe horizontal lines are made for y's. And that's absolutely right. So which one of these circled problems passes the horizontal line test? That would be option 4. Because if you look at option 1 and you draw a horizontal line anywhere on the graph, it crosses more than once. It is not one-to-one. It's still a function. So 1 is a function, but it's not one-to-one because it fails the horizontal line test. If you draw a horizontal line anywhere on 4, it passes. We got a quick explanation of the horizontal line test, but you just got that from me. And so now we can answer a question like number 4, which of the following represents a graph of a one-to-one function. So as you're looking at it, it must pass both the horizontal line test and vertical line test. So as you're looking at option 1, fails the vertical line test, so that's not right. Option 2 does pass the vertical line test, but it fails a horizontal line test. So that's not right. 3 is where it's at. So it passes everywhere. And 4, just like in the previous exercise, fails the horizontal line test. It does pass the vertical line test again. I know I am rushing a little bit because I just want to get all these notes done. If this were a normal school year, we were in the classroom, I would direct you guys to Desmos to explain this problem. Because if you went to Desmos and you typed in that equation, you would find out that shifted right 5. Absolute value is that V shape. I don't know if you've learned this before. And I think just by looking at the graph then, it clearly fails the horizontal line test. But another way of explaining why it's not a function is if you were to pick out 2 values for x. So I'm just going to start with an easy number like 0. Well, 0 minus 5 is -5. And the absolute value of -5 gives you +5. So can you think of another x value that would still give you a +5? Well, I'm not looking for you to speak up because the consent, if you don't want to be on video, that's fine. But maybe you're thinking about x being 10. See how it's a different x value? But when I plug in 10 minus 5, I get the absolute value of 5. So I have y values that repeat. So this is an example of 2 x values that give you the same y value. So the y's repeat, and it's not a 1-to-1 function.